Okay, we're now going to consider just a slight extension, and that is the distance from a point off the plane to a plane. So let's get out our trusty plane again. Here he is. That's the plane. Let's say he's got equation x plus y plus z is equal to 2, and we've got a point. Off the plane. So let's say this point here. Let's give him coordinates -1, 1, -1, and we want to find the distance from this point to the plane. So it'll be the perpendicular distance to the plane here, such that, if there's a vector on the plane here, we have a right angle. So this is my normal vector, if you like. So we know what its direction is, don't we? We can pick that up from our Cartesian equation of the plane. So we can say here that my direction vector is equal to 1, 1, 1. All right, which is which is our normal vector. So that's my direction vector, and I've got a point. So now I've got enough information here to construct a vector equation. So I can say therefore I've got a vector equation of the line. So I should say this, therefore vector equation of perpendicular, I could just say normal, and that's going to be r equals, I've got my fixed point -1, 1, -1, and I've got my direction vector 1, 1, 1. So therefore I have my parametric equations of x is equal to -1 plus lambda, y is equal to 1 plus lambda, z is equal to -1 plus lambda. So we have we are now able to find the point of intersection that this normal makes with the plane. So the sequence of events here is to find the direction vector of our normal, then construct a vector equation in order that we can then use what we've just learned about finding the point of intersection of a line and a plane. So our line now is the normal, and the plane is x plus y plus z equals 2. So we're going to substitute my x, y, z here, my lambda values, my x, y, z, my parametric equations into my equation of the plane, and find the value of lambda that solves that. That'll give me the point of intersection down here, that point right there. Okay, so let's get to work on that computation. So therefore -1 plus lambda plus 1 plus lambda plus -1 plus lambda is equal to 2. So therefore 1, 2, 3 lambda -1 plus 1 minus 1 is equal to 2. 3 lambda equals 3, so lambda is equal to 1. So therefore my point of intersection is equal to, where are we? -1 plus 1, so 0. 1 plus 1, so 2. -1 plus 1, 0, 2, 0 is our point of intersection. So we've now found this point here. It is at 0, 2, 0. 0, 2, 0. So now we have 2 points, and that is the shortest distance from point to plane. So therefore I can work out from that, I can get my distance, which is equal to the square root of 1 squared plus 1 to 2, 1 squared plus 1 squared. So that's equal to the square root of 3. Okay, a fairly straightforward example. You are not going to see much more difficult than that, because actually doing it in this way, which is all the course really wants you to do, and that is really by first principles, by finding this point of intersection. Often finding this point of intersection here can take quite a bit of work, and therefore we've got a lot of number crunching to find our distance. The course here really just in order for you to be able to access the distance in using this method, then you have to be dealing with fairly simple numbers, integers. Otherwise, it gets really messy. So there's an example. It's in exercise 11p. So I'd like us now to go and complete exercise 11p. I think I asked you to do 1 and 2. So if we can now do questions 3 through to 5, that would be great. Cheers.